Hello, welcome everybody to the final plenary session. My name is Javier Riverola and I have been honored to be the chairman of this last session before we undergo a spontaneous discussion session later. In this last session, we have 3 speakers today. We have Mr. Juan Antonio Burillo from Technatom, also Tom Anklem from Lawrence Livermore National Laboratory, and Mark Sinks from the Belgian Nuclear Research Center. Okay. First presentation is going to be done by Mr. Burillo. So Juan, when you want. Let me remind you, it's 25 minutes for each presentation, and then 5 for questions. But don't feel too constricted, okay?
Okay, thank you. Good afternoon, everyone. My name is Juan Burillo. I'm working as responsible for the IPO 1000 training in Technatom. This is my current position and responsibility. Today, I have the pleasure of address a presentation to you about the development of a staffing model to operate the emerging nuclear energy. My presentation today will be split into parts, 2 sections. First one will be about developing a training system, and the second one will go into a reflection about how the new technology will impact in the future on training issues. The objective is to present an approach to achieve an effective nuclear training system for the new coming plants. And this is a compile of experience on our daily work dealing with the new plants construction, especially the advanced passive systems, and mainly with the new layouts and setups on the digital control rooms. Later in the presentation will be the enormous impact that this new arrangement in control rooms have on training. For developing a training system, we want to assure the effectiveness of the nuclear training, and for do that, we need to implement a comprehensive training system, and in order to fulfill this goal, we have to plan a strategy to develop and implement with a long time before we really start the plant. In our experience, this is a long period of time, ranging around 8 years. Sometimes it's difficult to convince clients and people involved in a new construction that you need 8 years to fulfill all the stages needed to go from one technology to an evolutionary technology, not completely different, but with some substantial improvements and different approaches. So we divide this period of time in 3 stages. First one is devoted to the human resources planning and licensing submission. The second one is about building the infrastructure. And the third one will consist of the certification and commissioning. The comprehensive training service for the new staff will start with the recruitment and selection of the first people working into the training. And that is people that are going to be the first set of instructors that after their training and developing the training material will teach the first formal crews that will operate the plant. So we have to hire them and we have to train them. we initially trained the people in a common technology base, and that consists of a full range of theoretical knowledge, system descriptions, operation, procedures. We also teach them radiological protection, human resources, and pedagogical issues, because they not only has to show their technical competence, but also to be people able to transmit and to encourage the new operators, and have to get special abilities and knowledge to give the lectures. Later, we'll go into the specific training, and for the first group of instructors, that is a phase where they're going to develop the specific training material. Since we are going from one technology, let's say a vintage technology, to an advanced or passive technology, these people has to implement all the lectures and specific knowledge and abilities for the new technology. The training strategy has different phases, and for the training quality plan and procedures, we develop procedures related to the training needs, analysis, that is the first phase, which according to the systematic approach to training methodology is the first phase we have to implement. Then the second phase will be the design of the training programs. When we get the job profiles, we design schedules and training programs for the different job positions. The third phase will typically is the development of the training materials. And the fourth phase is the implementation of training, the formal training. All the lectures, exams, and the instructor training and qualification. And finally, the last phase of the SAT methodology is the evaluation. Evaluation is an important task or phase, because will bring us the opportunity to have a feedback from the results of the training, and we can address problems, issues, and trying to find the solutions that will be back in the process and will be submitted to the analysis, design, development, and implementation again. Okay, going into the second stage, what we call the infrastructure, the building infrastructure, we have several milestones to do. Beginning with the simulator manufacturing, the first instructor qualification, the design of specific training programs for licensed and non-licensed personnel. This is just starting to make the approach to the new items or issues on the new technology. The recruitment and selection of the operating personnel, beginning with the licensing of the training program. And finally, the training center organization, design and building, classrooms, labs, workshops, and mock-ups, construction. Okay, this is about the phases of the SAT methodology I just talked about. And the third phase will be the certification and commissioning. And the main milestones for the last certification and commissioning is the simulator ready for training and the simulator configuration control system, the training of the operators and the participation and the commissioning, the operating procedures revision and updating, the RO and SRO license exams for reactor operator and senior reactor operators license exams, and the participation in the pre-operational tests, and finally the fuel load, which is the beginning of the operation of the plant. Here you have a picture of the old-fashioned simulators or control rooms, which differs much more from the new ones, as you know. And that is going to be the main argument for the second part of the presentation. Here we have a slide which shows resume of all the phases, put it on a time scale from 8 years to the full load, and we have all the phases that we are going through, from the initial selection of instructors, their training, the licensing submission, the SAT development, the training center, validation, final simulator ready for training, and the exams from the ROs, SROs, and the final fuel load, which is the beginning of the operation. And here you can find a summary of the deliverables that each stage of the process is related, okay? So it's a kind of resume or summary of all the deliverables, also related to the site support issues. And going to the second part is about the new technology impact on training. I'm going to have as a support of the presentation an empirical study who was published in 2000 by the NRC, and it was an empirical study done on the Halden laboratory in Norway, and this took the opportunity to have an international report done by the NRC, and the number is the 0137 Nurek, okay? And it's particularly interesting because it's based on real experiences. And the way this study was done, it was a comparison on the reaction of the real operators of Loviisa nuclear power plant in Finland between their performance in a standard simulator corresponding to the actual plant, to the current plant, and the Halden laboratory, which is a simulator with the same load, but with the different interfaces. Those interfaces were mainly monitors, and they were provided with computer-based procedure systems and an alarm, advanced alarm system, which prioritized the alarms. So the environment was completely different, and the study goes through different metrics to go into a evaluation between the staffing sizes on the two groups and the effects of these characteristics on the operating facility. So by comparing the conventional and the advanced control room, they envision what are the main aspects that can be different on this kind of operations. The metric uses to assess the operation and plan for performance were the task completion, the critical initiation time, and the control of parameters. Also, they were taking into consideration the situation awareness, the operator workload, the team interaction, and the rated crew performance. It was a number of conclusions or findings. And to make a summary, I will say that the situation awareness on the conventional and the advanced was better on the advanced control room. The reason for that mainly is because the kind of recorders, digital information, and the access to many much information for all the positions in the control room. While in the conventional control room, each operator was devoted to a part of the hardware control room, and they don't have as much information about the whole plant, but only about their assigned systems and responsibilities. And that is why the situation awareness is better on a compact advanced control room. In relation to the workload, the observations comes to the conclusion that workload was high in the small compact control rooms. And the reason for that can be found on the level of concentration that operators must have to search for the information and try to operate the plant from navigating through a huge number of screens. While the operation on a standard control room is more physics, the operation or the action to start a pump, for instance, is to grab a hand switch and just operate it, and usually the amp meter is on a side, and you can see the amp meter going up, and all the check-ins relating to that operation. It's much more simpler. So workload is not so high like in the compact control rooms. About team interaction is another metric used to evaluate the difference. Team interaction it's much more intense on the vintage technology. The communications, the level of noise and orders and verification is much higher, while you are operating in a digital control room. And the reason for that is pretty obvious. The amount of information is much more accessible for the operators in the compact control rooms, and they have the possibility of getting information from all the points of the plant. Therefore, the need for interaction and for communication is much more reduced. But this is one of the problems or possible problems that the operation of the new plants may have, in the sense of reducing the level of communication may conduct to a lack of information which has been shared among the members of the control room. And in order to overcome these possible problems, what has been proposed in different experiments is to force the team to make briefings and to have compulsory announcements and notifications to the other members of the crew. So some kind of new administrative requirements will be needed in the future control room plans. For instance, to finish these metrics and on the findings that this study come across, we will talk about the rated crew performance, which is being better on the compact control rooms against the standard layout, right? So, to come with the several bullets interesting to know, I will say that the ability to intervene with the automatic systems is necessary if the crew is to serve as a backup to automation. So we have to train people in order to be able to intervene in the control systems, especially with a high level of automation. Maintaining an awareness of the plant is normally higher, but we have to make sure to maintain the operator within the control loop of the operations. And finally, a validation process using measures of operators and crew are necessary to determine the staffing complements needed to operate the plants. And this is, again, related to the need of having studies and empirical experiments with the real technology to monitor the reactions, to search for the possible lacks or problems in the operation, and to serve as input for the new administrative instructions for the crews. And to have a very visual resume or summary between what is the conventional operational concept and the new one, I want to show you two slides. The first one reflects the conventional operational concepts. I put three points where the operation team are base their operating performance. First one is the training program. Second one is the control room. And the third one are the plant procedures, okay? And the operating team is in the middle of those resources that they have to operate the plant, and everything is related to the collaboration of the chief technical advisor, which is the person who typically are in charge of reading the emergency operating procedures and help the operating crew. If we go to the new proposed model, which contemplate the digital and the computer-based procedure systems and the new advanced alarm systems, it's much more complex. What we go into a model of where the chief technical advisor has to monitor the critical parameters. This is a different approach that the optimal recovery procedures give to the plan. And also, the chief technical advisor must get the information for the conventional instrumentation, while the operating team gets the information from the protection measuring system and uses the computer-based procedure systems and the new advanced alarm systems. This is a kind of double barrier which increases safety in our vision and give a much more safe operation, okay? So we go to the conclusions to finish. Conclusions, to assure effectiveness of the nuclear training, it is necessary to implement a planned, customized, comprehensive training system, depending on the technology. The strategy should be established at an early stage, around 8 years before the starting of the plan. Another great combination of nuclearization training program for the scientific and engineering community to become familiar with the nuclear specialties, and the specific SAT training program for the exploitation team is highly recommended. And finally, the validation process using measures of operator and crew performance are necessary to determine the staffing complements needed to operate the plant. And that is the presentation for today. Thank you for your attention.
Okay, we still have time for just 2 quick questions.
I guess this comparison you have shown, you have taken people from already existing plants which have a lot of experience with the old system. And so we are training, having a comparison with the old system and new system. So my question is, if you now take new people, young people, which are growing up with totally different technologies, do you see a preference then?
Yeah,
a difference between the young people which are growing up with new technologies and the more experienced people, elderly people?
Yeah, this is a very good question. I personally, I will talk to you about my experience in a project where we have to verify and validate a computerized base procedure system called Compro from Westinghouse and an advanced alarm system for the Swiss plant of Besnau, right? And that was done back in the 1999. We make a comparison of how the crew was performing with the paper procedures and the initial setup, and how the crew were performing on the use of the computer-based procedure systems and the alarm systems. And we did that with real crews, formal crews from the Besnau plant. And we see an amazing difference between the young people and the not so young people, right? They get used to the computers and to the digital systems much more quickly. And it's a big difference in performance, mainly because their ability or capability of learning new things, but not also for that, also for the how familiar they were with those systems. I'm talking about 13 years, 14 years, and at that time, emails were starting. So it looks close in time, but technology has evolved quite a lot since then. And young people at that time had much more experience than that guy ranging in the 40s or the 50s. They really have some problems, especially to navigate through the menus to find information. That is pretty obvious.
Okay.
I answered your question?
Thank you very much.
Thank you to you.
I think that we have stopped the time.